Welcome to This Explainer. Today we're embarking on what is honestly one of the most spectacular journeys our planet has to offer. It's something that happens every single day, right above our heads and right beneath our feet, and yet we kind of just ignore it, right? Well, today we're going to follow the absolutely incredible life cycle of rain. We're going to track a single drop of water from the vast, deep oceans all the way up into the sky and then all the way back down again. It's a massive story of transformation, gravity, and literally life itself.
So it all starts with a simple but honestly mind-boggling question. How does an entire ocean end up floating in the sky? Seriously, think about the sheer weight of a storm cloud for a second. We're talking trillions of gallons of liquid water just suspended miles above the Earth's surface. I mean, it completely defies our basic intuition of gravity, doesn't it? How on earth does it get up there? And what kind of magical mechanisms keep this endless cycle moving day after day, year after year?
Well, to answer that, let's start with part one, the invisible ascent. This is all about sun, heat, and convection.
Okay, let's dive into this. This initial phase is really the engine of the entire system, and it's driven completely by the sun and intense heat. Without this initial push, our skies would be completely empty. So the process kicks off with the sun beating down on the Earth, heating up basically any body of water it touches. Now, the oceans are the biggest contributors, obviously, because they cover most of the planet. But it's not just the oceans. The sun is also heating up rivers, serene lakes, and even the wet ground in your backyard after a morning dew. As this water heats up, the liquid transforms into invisible water vapor. It literally just vanishes into thin air. It's this silent, massive, constant migration of water from the surface right up into the atmosphere. But wait, how does that vapor actually travel upward? Well, that brings us to convection. Convection is simply the process where warm, moist air is lifted and rises high into the atmosphere via thermal updrafts. You can kind of think of these updrafts as massive, invisible elevators. As the sun bakes the Earth, that hot, vapor-rich air surges upward, carrying our invisible ocean higher and higher into the sky and pulling it far, far away from the surface. That brings us to part two, birth of a cloud. This is where cooling and condensation come into play. So, as our invisible elevator goes up, the environment outside starts to change drastically. Let's break down this step-by-step microprocess. Step 1, the invisible water vapor rises via convection. Easy enough. Step 2, as that air reaches higher and higher altitudes, temperatures drop incredibly fast. The atmosphere, way up there, is freezing cold. And that leads directly to step 3. Cold air simply cannot hold as much moisture as warm air, so the vapor is basically forced to transform back into a liquid state. It condenses into microscopic, tiny water droplets. The invisible suddenly becomes visible again. Now, what's really interesting here is that this condensation actually can't happen in empty space. The vapor absolutely needs a physical anchor, what scientists like to call cloud condensation nuclei. See, high up in the atmosphere, just floating around, are billions of microscopic pieces of debris. We're talking about tiny specks of dirt and dust, pollen carried by the wind from distant forests, and even salt particles swept up from crashing ocean waves. The water vapor latches onto these tiny anchors, condensing right around them. Millions of these tiny wet particles gather together and boom, suddenly you have a cloud. So now we've got this enormous structure made of tiny water droplets suspended in the freezing upper atmosphere. But they can't stay up there forever, right? As more and more moisture is pumped up by our invisible elevator, the cloud gets denser and heavier. So, what happens when the cloud just can't hold any more weight?
Well, that triggers part 3, the Great Fall. It's time for coalescence and gravity. This brings us to the real climax of the water cycle, where the physics of coalescence and the raw power of gravity finally take over. That gentle floating is about to end. To understand why rain falls, we have to understand coalescence. That's the process of tiny water droplets colliding and merging together to create much larger, heavier droplets. Inside that dark storm cloud, it is incredibly chaotic. Winds are whipping around, and those microscopic water droplets are crashing into each other like tiny bumper cars. And when they crash, they stick together. 2 become 1, then 4 become 1, getting bigger and bigger. Eventually, these droplets become entirely too heavy for the air currents to keep them suspended. Gravity finally wins the tug-of-war and violently pulls them back down to Earth.
Of course, gravity pulls this water down in varying intensities, which is why we get completely different experiences on the ground. If the droplets only coalesce a little bit and stay relatively small, they gently drift down as a light drizzle. But if the cloud is super thick and the coalescence happens rapidly, creating massive, heavy drops, gravity yanks them down fast, and you get a torrential, heavy thunderstorm.
And, naturally, you have your standard, steady rain sitting right in the middle. The type of rain we experience is quite literally a direct mathematical result of the weight of the droplets fighting against the air.
Moving on to Part 4, Rain's Impact on Earth. Replenishing Life.
The incredible journey down finally ends as the water makes contact with the surface. All that crazy drama in the sky gives way to a quiet, wondrous renewal on the ground. And this brilliantly illustrates exactly why this entire cycle matters. Just look at where this water lands. It falls over vast forests and sprawling farms, providing the literal lifeblood for the plants and crops that sustain our entire food chain. It crashes into rivers and lakes, refilling the reservoirs that we rely on every single day. It washes over cities and our human infrastructure, eventually finding its way to the drainage systems. It blankets the tops of mountains, where it'll eventually melt and flow downwards. Every single drop is replenishing a water supply and supporting life in incredibly diverse environments all across the globe.
Which brings us to Part 5, the endless cycle, returning home.
You see, the story doesn't just end when the droplet hits the dirt. The water cycle is exactly that, a cycle. The fallen rainwater immediately starts moving. It seeps into the soil, it runs down the sides of mountains, it joins tiny streams that feed into massive rivers, and eventually it all flows right back into the lakes and oceans. Let's look at the actual timeline of this incredible loop. It might take days for the sun to sufficiently heat the ocean water. It takes hours for that invisible vapor to rise up via convection. It can take mere minutes for condensation to suddenly form those massive, heavy clouds. It takes only seconds for gravity to pull that heavy rain down to the ground. And then, it can take months for that water to slowly snake its way through the rivers and flow back out to the sea. It is a continuous, unbroken, chronological loop that just constantly resets itself.
And hey, when the storm finally clears, we're often left with a rainbow. Now, this isn't just a pretty picture. It's actually a fascinating optical phenomenon that only exists because those newly coalesced droplets act as billions of microscopic prisms, bending the returning sunlight. It's a profound visual symbol of this whole system. I mean, sure, it represents the peace after the chaos of a storm, but more importantly, it emphasizes the absolute vital necessity of this cycle. Without the rain, the Earth literally turns to dust.
I want to leave you with this absolutely incredible thought to wrap up our explainer today. Because this system is a completely closed, endlessly repeating loop, the water is constantly being recycled. That means the water sitting in a tiny muddy puddle outside your house right now might have once, millions of years ago, been part of an ancient prehistoric ocean. Every single drop has been on this journey billions of times. So, the next time you feel a raindrop on your face, you really have to ask yourself, what ancient worlds has this exact drop of water touched before it finally reached you?